Good day, everyone. My name is Chimach Irwa, and I am thrilled to be here today to lead our discussion. Our topic is one that I believe is very relevant and thought-provoking. We will be delving into implicit differentiation, higher-order derivatives, maxima and minima, and the time rates. I am looking forward to hearing your diverse perspectives and engaging in a fruitful dialogue. So let's begin. First, we are talking about the implicit differentiation. What is implicit differentiation? Implicit differentiation is a differentiation in a calculus method used when variables are given implicitly. It is involved in differentiating both sides of an equation and applying a chain rule. So today I'm going to explain to you the answer of the problem number one step by step. So our problem number one is x cubed plus y cubed is equal to 4. Then we proceed to step 1. Multiply both sides of the function by d over dx. In our solution, we multiply both sides by d over dx and it can be written into d over dx times x cubed plus y cubed is equal to d over dx 4. And also it can written into x cubed d over dx plus y cubed d over dx is equal to 4 d over dx. Then in our step 2, we differentiate x cubed d over dx and 4 d over dx with respect to x. To differentiate the problem, we will use chain rule. The derivative of x cubed d over dx is 3x squared plus y cubed d over dx is equal to derivative of 4, which is 0 because it's constant. And as you notice, I can differentiate y cubed d over dx because in our step 3, we noted that we cannot differentiate y cubed d over dx with respect to x as above, since it is written in terms of y. Then we proceed to step 4. We perform the chain rule on y cubed d over dx by first differentiate y cubed with respect to y, and second is multiply the result by d over dx. And our goal of this is to solve the derivative of y cubed. So, to differentiate y cubed by the use of chain rule, we will multiply y cubed to dy over dx and it can written into the differentiate or the derivative of y cubed is equal to the derivative of y cubed times dy over dx. And by the use of chain rule, we will written the answer into 3y squared times dy over dx. And then, in proceeding our step 5, which is let d over dx y cubed is equal to 3y squared times dy over dx and solve for dy over dx. So, we know that the derivative of y cubed with respect to y is 3y squared times dy over dx, and I can written as 3x squared plus 3y squared dy over dx is equal to 0. Then, on this situation, we will transpose the 3x squared to the right side. By transposing the 3x squared, it can also change its sign from positive to negative. Then, to proceed the next step, we will divide both sides by 3y squared, and then cancel the 3y squared from the left, and it can written into dy over dx is equal to negative 3x squared over 3y squared. Then, as you notice, we can divide the numerator and denominator to 3, and then our final answer is dy over dx is equal to negative x squared over y squared. So that is the solution in my answer of problem number 1 in our implicit differentiation. So we will proceed to the next topic, which is the high order derivative. Now we are into our next topic, which is the higher order derivatives. Before we proceed to answer the problem, let's define first what is higher order derivatives. Higher order derivatives are derivatives beyond the first, obtained by differentiating a function multiple times. They represent rates of change of rates. Now, I'm going to explain to you the step-by-step procedure in problem number 18, which our function is y is equal to fifth root of x cubed plus 3x minus e to the power of x squared plus 5. Then, let's proceed to our first step. Our step 1 is converted the function to make it easier to solve. So from the function y is equal to fifth root of x cubed plus 3x minus e to the power of x squared plus 5, we converted it into y is equal to the quantity of x cubed plus 3x to the power of 1/5 minus 8x to the power of 2 plus 5. Then our final function is y is equal to the quantity of x cubed plus 3x to the power of 1/5 minus e to the power of x squared plus 5. Then proceed to our next step, which is the step 2. Find the first derivative of a function by the use of chain rule and exponential derivatives. So, by the use of the chain rule and exponential rule, we can find the first derivative. So, the derivative of a function y is equal to the quantity of x cubed plus 3x to the power of 1/5 minus e to the power of x squared plus 5 is equal to 1/5 the quantity of x cubed plus 3x to the power of 1/5 minus 1, and then the derivative of the x cubed plus 3x is 3x squared plus 3. Then the derivative of e to the power of x squared plus 5 is equal to negative e to the power of x squared plus 5, and then the derivative of x squared plus 5 is 2x. Then we can simplify it and can rewrite it into 1/5 the quantity of x cubed plus 3x to the power of negative 4 over 5 times 3x squared plus 3 minus 2x e to the power of x squared plus 5. So let's proceed to the step 3. Find the second derivative of a function by the use of product rule. We all know that the first derivative of a function is 1/5 times x cubed plus 3x to the raised to the power of negative 4/5 times 3x squared plus 3 minus 2x e raised to the power of x squared plus 5. Then we will find the second derivative by the use of product rule. So the second derivative is 1/5 bracket x cubed plus 3x to the power of negative 4/5 times 6x plus 3x squared plus 3 times negative 4/5 times x cubed plus 3x to the power of negative 9/5 times 3x squared plus 3 minus 2x times e to the power of x squared plus 5 times 2x plus e to the power of x squared plus 5 times 2. Then we will simplify it into 1/5 6x times x cubed plus 3x to the power of negative 4/5 minus 4/5 times 3x squared plus 3 raised to the power of 2 times x cubed plus 3x to the power of negative 9 fifth minus 4x squared e to the power of x squared plus 5 plus 2e raised to the power of x squared plus 5. Then we simplify it into 6x over 5 times x cubed plus 3x to the power of negative 4 fifth minus 425 times 3x squared plus 3 to the power of 2 times x cubed plus 3x raised to the power of negative 9 fifth minus 4x squared ex 2 plus 5 plus 2e raised to x squared plus 5. Then our final answer is 6x over 5 times x cubed plus 3x raised to the power of 4 fifth minus 4 times 3x squared plus 3 raised to the power of 2 over 25 times x cubed plus 3x raised to 9 fifth minus 4x squared ex 4x squared e raised to the power of x squared plus 5 plus 2e raised to x squared plus 5, or we can write it into 6x to the over 5 fifth root of x x cubed plus 3x to the power of 4 minus 4 times 3x squared plus 3 raised to 2 over 25 fifth root of x cubed plus 3x raised to 9 minus 4x squared e to the power of x squared plus 5 plus 2e raised to x squared plus 5. So that is the step-by-step procedure of higher order derivatives. And now let's proceed to our next topic, which is the maxima and minima. First, let's define what is maxima and minima. Maxima and minima are the highest and lowest points of function, respectively. They represent the function extremes values within a given range. So let's proceed to the problem solving in this topic. So our problem number is 506. Find the minimum distance from the point 4 and 2 to the parabola y squared equals if x. So in the first steps, we substitute the 4 and 2 in distance formula. Our distance formula is d is equal to the square root of x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2. Then we substitute the 4 and 2 in the formula. So d is equal to the square root of x minus 4 raised to 2 plus y minus 2 raised to 2. Then we find the value of x in y squared equals to 8x. So y squared equals 8x. To, to find the value of x, we divided both sides by 8. So y squared over 8 is equal to 8x over 8. So cancel the 8 in the right side and remain the x. So the the value of our x is y squared over 8. Then in our next step, we substitute the x equals y squared over 8 in the distance formula. So our distance formula again is d is equal to square root of x minus 4 raised to 2 plus y minus 2 raised to 2. So we substitute the x. So d is equal to the square root of y squared minus 8 minus 4 raised to 2 plus y minus 2 raised to 2. Then note that d square root of u equals the du over 2 square root of u. In our next step, we differentiate and use the chain rule. So we will differentiate the y squared over 8 minus 4 raised to 2 in by the use of the chain rule. So the derivative of 8 is equal to 2 times y squared over 8 minus 4 times the derivative of y squared over 8 minus 4 is y over 4. Then we derive also the y minus 2 raised to 2. So the derivative of this is 2 times y minus 2 and the derivative of y minus 2 is 1. So it can be 2 times y minus 2. Then we substitute on our formula d square root of u is equal to du over 2 square root of u. So to differentiate the value of y and x, so let's substitute the derivative of y and x to this formula. So g prime is equal to 2 times y squared over 8 minus 4 times y over 4 plus 2 times y minus 2 over 2 square root of y squared over 8 minus 4 raised to 2 plus y minus 2 raised to 2. Then we equate the d prime to 0. So by equating the d prime to 0, we will cross multiply the function. So after cross multiplying the function, the remaining values of the function is 2 times y squared over 8 minus 4 times y over 4 plus 2 times y minus 2. So we simplify the 2 to the y squared minus 8 minus 2. So it can be written into 2 minus 2 over 8 minus 8 times y over 4 plus 2y minus 2. So we'll notice that the 2 times y minus 2 can be simplified. So we simplify it by 2 times y is 2y and 2 negative times negative 2 is negative 4. And then in this solution, we will notice again that the y over 4 can be simplified to the y squared over 4 minus 8. So y over 4 times y squared over 4 is y cubed over 16. Then y over 4 times negative 8 is negative 8y over 4 plus 2y minus 4. Then we notice that the 8y over 4 can be divided. So we written it into y cubed over 16 minus 2y plus 2y minus 4. Then we notice again that the negative 2y plus 2y can be cancelled. So it can be y cubed over 16 minus 4. Then we transpose the negative 4 to the left side. So the negative 4 can be positive from negative sign to positive sign. Then we proceed to cross multiplication. So 4 times 16 will be 64 and y cubed times 1 will be y cubed. Then cube root both sides of the function. So the cube root of y cubed equals the cube root of 64 is y is equal to 4. So let's proceed to the next step. We substitute the y equals 4 in the x equals y squared over 8. So we substitute the y equals 4 to the function of x. So x is equal to 4, which is our y, raised to 2 over 8 is equal to 2. Then we substitute that the x is equal to 2 and y is equal to 4 on the distance equation. So our distance equation is t equals square root of x minus 4 raised to 2 plus y minus 2 raised to 2. Then, in substituting it, we written it into d equals square root of 2 minus 4 raised to 2 plus 4 minus 2 raised to 2. Then d is equal to 2 minus 4 equals 2, then raised to 2 plus 4 minus 2 is 2, then raised to 2. So 2 times 2 is 4, plus 2 times 2 is 4, plus 4 plus 4 is 8. So d is equal to square root of 8, or we can write it into 2 square root of 2 unit length. So our final answer is 2 square root of 2 unit length of this problem. So that is the step-by-step procedure of maxima and minima in the problem 596. So let's proceed to the next topic. Our next topic and last topic is the time rate. Before we proceed to the problem solving, let's define first what is time rate. Time rate refers to the rate of change of a quantity with respect to time. It's calculated by differentiating the quantity with respect to time. So in our problem solving, we solve the problem number 617. A man walked across a bridge at the rate of 5 fps as a boat passes directly beneath him at 10 fps. If the bridge is 10 feet above the boat, how fast are the man and the boat later? So we have a diagram here. Then we solve for the problem. So s squared is equal to 10t raised to 2 plus 5t raised to 2 plus 10 squared. So s squared is equal to 10 times 10 is 100, then t times t is t squared, so 100t squared, and 5t times 5t is 25t squared, and then the square root of 10 is 100. Then t squared is equal to 125t squared because 100t squared plus 25t squared is 125t squared, then copy the 100. Then we differentiate this function. So 2s times ds over dt is equal to 50, or 250t. Then by dividing both sides by 2s, so the 2s from the left side will be cancelled and the 2s from the right side will be remain. So it can be written as ds over dt is equal to 250t over 2s. So when t is equal to 1 second, then we substitute 1 in the formula. S squared equals 125 t squared plus 10. So what we substitute the 1 to this formula. So s squared equals 125 1 to the power of 2 plus 100. We all know that the square root of 1 is always 1. So 1 times 125 is 125. So 125 plus 100 is equal to 225. Then we squared both sides. So the square root of s squared equals square root of 225 is equals 15 feet. Then in the next step, we substitute s equals 15 and t equals 1 to the ds over dt equals 250t and 250t over 2s. So we substitute the S and T to this function, to this formula. So ds over dt equals 250 times 1 over 2 times 15. So ds over dt equals 250 over 30. So if we divide the 250 over 30, our final answer will be ds over dt equals 8.33 fps. So that is the step-by-step procedure of the maxima and minima topic. As we come to the end of our presentation, I would like to take a moment to reflect on what we discussed today. We delve into some complex topics, share insight, and hopefully spark some new ideas. I want to express my sincere gratitude to all of you for your time and attention. Your participation and engagement have made this presentation a success. Remember, the conversation doesn't have to end here. I encourage you to continue exploring this idea and asking questions. Thank you once again for joining us today. Stay safe and take care. Goodbye and see you next time. So,